In this episode, we're going to walk through the Linux file system layout in a way that makes it feel like a map, not a pile of random folders. Because the exam loves to test whether you understand what belongs where and why that location matters. New learners often treat directories as arbitrary names you just memorize, but Linux uses structure on purpose, and that structure becomes a shortcut for reasoning. If you know what a directory is intended for, you can predict what kind of files you might find there, what changes are safe, and what actions are risky, even when you have not seen that exact system before. The Filesystem Hierarchy Standard, FHS, is the set of conventions that describes common directory roles across Linux systems. And while not every distribution is identical, the standard gives you a reliable baseline. The exam uses this topic because it connects daily navigation with deeper ideas like boot, configuration, software installation, logs, and user behavior. By the end, you should be able to explain the big purpose of the major directories and understand how location becomes a clue in troubleshooting style questions. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A helpful mental model is to imagine the file system as a city where different neighborhoods exist for different reasons, and the rules of the neighborhood tell you what belongs there. In Linux, everything starts at the root directory, written as /, which is the top of the tree that everything else hangs from. When you see a path, the directory names are telling you context, like whether something is essential for boot, whether it is meant to change frequently, or whether it is shared and reusable. The standard exists because administrators and software need a predictable place to find core components, and predictability reduces risk, especially during boot and recovery. On the exam, a path is often more than a location. It is a hint about the nature of the file and its importance to the system. If a question mentions a file in a directory that is meant for configuration, that suggests one kind of reasoning, while a file in a directory meant for variable data suggests another. This is why the FHS is not just a memorization topic. It is a logic topic disguised as a directory tour. Let's start with the directories that matter most for early startup and core system survival, because these are the ones you should treat as foundational. The /boot directory is commonly used to store boot-related files such as kernel images and bootloader components, and the reason it stands out is that it supports the system before everything else is fully available. The /bin and /spin directories historically contained essential user and system binaries, meaning core commands and tools needed to operate the system, especially in recovery contexts. Modern distributions sometimes merge these with other locations, but the exam still tests the idea that there are essential tools that must be available even when the system is in a limited state. The /lib directory historically held essential shared libraries needed by core binaries, and it also commonly relates to kernel modules and low-level support files. The common thread is that these directories are about minimal survivability. They contain things the system needs to boot and function at a basic level. When you see these paths in a question, your instinct should be caution, because changes here can have system-wide impact. Next, consider /etc., which is one of the most important directories to understand because it is where system-wide configuration is traditionally stored. The files in /etc. are often plain text configuration files that define how services behave, how the system identifies itself, what users and groups exist, and what rules apply to networking and security. The exact contents can vary, but the purpose stays consistent. /etc. is where you look for configuration, not where you put large data files or applications. This matters because exam questions frequently revolve around the idea that behavior changes come from configuration changes, and /etc. is the center of that world. If you see a problem described as a service behaving incorrectly after a change, it is natural to suspect configuration in /etc. rather than executable code. Another exam-friendly pattern is that /etc. is expected to be backed up and managed carefully, because losing configuration can make a system unusable even if all the software remains installed. When you think of /etc. as the system's policy binder, you can predict that it will contain the rules that control behavior. That prediction helps you pick the correct answer when paths are part of the choices. Now let's talk about /var, because it is easy to misunderstand, and misunderstanding it leads to mistakes in both real life and exam questions. The name /var comes from variable, and it is meant for data that changes as the system runs, like logs, caches, and spooled data waiting to be processed. If /etc. is the policy binder, /var is the activity record and the staging area for ongoing work. Logs are a classic example because they grow over time and reflect system events, which is why you often find logs under /var/log. Another example is temporary runtime state for services, queues, and other changing operational data. On the exam, /var is a clue that you are dealing with growth, change, and runtime behavior rather than static configuration. It is also a clue for disk space problems, because variable data can expand unexpectedly and fill storage, causing services to fail in strange ways. If you know what belongs in /var, you will understand why a system might behave unpredictably when /var cannot accept new writes, even though core binaries still exist. A closely related idea is temporary storage, and learners often lump several directories together without understanding the intention behind each one. The /tmp directory is intended for temporary files, often created by programs and meant to be discarded, but the key point is that temporary does not mean unimportant at the moment it is used. Temporary files can be essential during a program's run, but they are not meant to be long-term storage. Many systems treat /tmp as a place that may be cleaned automatically, which means you should not rely on it to store anything you cannot lose. There is also a /run directory on many modern systems that stores runtime state information that exists while the system is running, such as certain kinds of process-related or service-related state. For exam reasoning, the important distinction is that /tmp is a general scratch space, while /run is more like a structured runtime state area tied to the current boot session. When you see a path under /run, it suggests current state and boot session context, not long-term configuration. Understanding these intentions helps you interpret questions about what persists across reboots and what does not. Now let's shift to user-focused directories, because Linux makes a clear distinction between system-owned space and user-owned space, and the exam often tests that boundary indirectly. The /home directory is where user home directories typically live, and a home directory is the personal workspace for a user's files, settings, and preferences. This is where documents, downloads, and user-specific configuration files often live, and it is intended to be separate from the core system so user data can be managed independently. There is also the /root directory, which is the home directory for the administrative superuser, and it is separate from /home for both historical and security reasons. The key exam concept is that user data and user preferences should not be mixed into system directories like /etc., and system configuration should not be stored in user spaces. When a question asks where a user-specific configuration belongs or where a user would store personal data, /home is the natural answer. When it asks about system-wide behavior, /etc. and other system directories become the focus. The /usr directory often confuses beginners because the name looks like user, but its role is more like shared, installable software and resources that are not required for the most minimal boot environment. Historically, /usr contained a large portion of installed programs, libraries, and documentation, and it can be thought of as the main area for distribution-managed software. Many systems place many commands in /usr/bin and many system administration tools in /usr/spin, and they rely on /usr/lib for associated libraries. The important exam idea is that /usr is part of the system software world, not the personal user world, despite its name. One reason this matters is that some systems are designed so that /usr can be mounted separately, which creates interesting boot and recovery implications. If /usr is unavailable, certain programs might not run even though the core system is present, and that can create a failure mode where the system boots into a limited state. You do not need to memorize every subdirectory, but you do need to know that /usr is where much of the installed software lives, and it is logically separate from /etc. configuration and /var variable data. Another directory that matters for exam reasoning is /opt, which is commonly used for optional or third-party software that is not managed as part of the core distribution layout. The idea behind /opt is to keep add-on software organized so it does not scatter files across many locations, which can simplify management and removal. When you see /opt, think of software that was installed deliberately outside the usual distribution package paths, often by an organization or a vendor. This can matter in exam questions because it hints at a different management approach, like software that might not follow the same update or configuration patterns as distribution-managed software. It also affects troubleshooting because if a program lives under /opt, its configuration and data might also follow vendor-specific conventions rather than typical system conventions. The exam might not dive deeply into /opt, but it can use it as a clue about how software was installed and how it might be maintained. The broader skill is recognizing that location implies origin and intent, and that origin and intent influence safe decisions. Device files and pseudo-file systems are another area where location is an important clue, and this is where /dev and /proc stand out. The /dev directory contains device files, which are special entries that represent hardware devices or virtual devices, and they allow programs to interact with devices through the file system interface. The /proc directory is a pseudo-file system that provides information about processes and kernel state, exposing system details in a structured way. Both of these are not normal file storage. They are interfaces, and treating them like normal storage is a mistake. On the exam, if a question mentions something under /proc, it is often pointing to system status, process details, or kernel-level information, not to a configuration file you edit permanently. Similarly, /dev entries represent devices, so a path there is often about what devices exist and how they are represented, not about static data. The key reasoning skill is to recognize that some directories contain real files, while others are windows into system state, and the meaning of a path depends on that difference. There is also /sys, which, like /proc, provides a structured interface into kernel and device information, often representing hardware and driver relationships in a hierarchical way. You do not need to master the internal layout for the exam, but you should understand that /sys is another view into kernel-managed objects and device relationships. Together, /proc and /sys are part of how Linux exposes system state in a file-like way, which is powerful but also easy to misinterpret if you think everything is a regular file. The exam can use these directories to test whether you understand what is persistent and what is generated dynamically. If something is generated dynamically, it reflects the current state of the running system and may change from one moment to the next or from one boot to the next. If something is persistent configuration, it belongs in places like /etc. This distinction is a common exam theme because it tests conceptual understanding rather than rote memorization. Another big reason location matters is that it connects directly to security and least privilege, even when the question does not explicitly mention security. System directories like /etc, /bin, /spin, and many parts of /usr are typically writable only by administrative users, because changes there can affect the entire system. User directories under /home are typically writable by the user because they are personal workspace. Variable data under /var may be writable by services that need to log or store runtime data, but that access is usually controlled carefully. The exam often uses this as an indirect clue. If a task involves changing system-wide behavior, it likely requires access to protected locations, and if a task involves personal settings, it likely belongs in a user's home. Understanding the FHS gives you a natural way to reason about what should be protected and what can be flexible. It also helps you interpret permissions and ownership topics later, because you will already have a sense of what kinds of directories are high impact. Location becomes part of your threat model, even if you never use that phrase. Finally, let's address the practical exam angle, which is that many questions are really asking, do you understand the difference between configuration, software, variable data, and system state, and can you choose the correct place accordingly? If a question is about where to find logs that explain what happened, /var is a strong clue. If it is about where system-wide service behavior is defined, /etc is the natural location. If it is about user-specific files and preferences, /home is the intended space. If it is about devices and live kernel state, /dev, /proc, and /sys are the interfaces you think about, not ordinary storage. If it is about boot support, /boot becomes relevant. And if it is about add-on vendor software, /opt is a signal. You do not need to know every single directory to use this effectively. You need to know the intent of the major neighborhoods and trust that intent. The exam rewards the ability to infer and eliminate, and directory intent is a powerful inference tool. By the end of this tour, you should be able to describe the Filesystem Hierarchy Standard as a convention that turns Linux paths into meaningful clues about purpose, risk, and expected behavior. You should also be able to explain why location matters. It influences what persists across boots, what changes during runtime, what is protected, what is user-owned, and what is generated dynamically by the kernel. That understanding makes exam questions easier because a path is no longer a random string. It is evidence about what kind of file you are dealing with and how it should be managed. As you move into later topics like packages, services, and troubleshooting, you will keep using the same mental map because software, configuration, logs, and runtime state each tend to live in predictable places. If you practice reading paths as signals, you will answer faster, avoid traps that rely on name confusion, and make safer choices when multiple answers sound plausible. Most importantly, you will feel like Linux has an internal logic you can follow, rather than a collection of arbitrary traditions you must memorize.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.